it. We have made it to the end of Module 2. So we have covered Chapter 4, and after this video, which is Section 6.2, we will have covered all of Chapter 6 that we are wanting to cover because 6.3 is optional. So in this one, we're still talking about probability distribution functions. We're going to focus more in on the continuous type of numerical variable for probability distributions. So that's the big goal in this one. We are going to be using the calculator to do some things, okay? And we're going to be using second and hit variables, which brings up this DISTR, which is distributions. And we're going to be looking at number 2 to help us out, okay? So that's what we're going to be dealing a lot with. So second and variables to bring up distributions. And then we also have this nice little draw feature right here where we can do some shading and stuff like that, but more on that later on, really. But the big thing is under distributions, we're going to be looking at number 2. Okay, I know this one says PDF right there, but this is actually going to be the one that we want to use. Okay, so we've got that. And then in StatCrunch, we'll be using stats, calculators, and down here at normal. Okay, so stat, calculators, and down here at normal is what we're going to be using. So those are the two things. I like StatCrunch a lot more than the TI-84, but I want to show you both, okay? Because you have both at your disposal. So in 6.2, we're going to talk about what we call a normal PDF or normal probability distributions, which we call the normal model. Okay, the normal model is used quite a lot in statistics because a lot of things model the normal model. Okay, so as I kind of said right here, I've got, well, I should have covered this up. I don't know why I didn't. Right here, it is the most widely used model for continuous numerical variables. Okay, it is the widely used one because a lot of stuff mimics in real life the normal model. Okay, so there's that. Some other things. It is used for unimodal and symmetric displays, hence why we use it a lot. Okay, and if you're not sure if your model or the information you have is unimodal and symmetric, then you can take your data and you can draw a histogram to it to check it out. So you can always double check this by having StatCrunch draw the histogram for you. Okay, so you can always double check this. But we use this for unimodal and symmetric because the normal model lays pretty well and is pretty close to aligning and matching unimodal symmetric displays. Okay. So then from here, okay, we're frozen. Come on. There we go. Just some other names we have for it. We also call it the normal curve, the normal distribution, or the Gaussian distribution because it was discovered by Gauss. Okay, so all these are the same thing: normal model, normal curve, normal distribution, Gaussian distribution. Most of the time, we just call it the normal model or the normal curve. Okay, very rarely will you hear me say the Gaussian distribution. But these are other names. They all mean the same thing. There is some new notation now. Okay, so we have this Greek symbol. It is the lowercase letter for mu. Okay, so this means the mean of the probability distribution. Okay, now the reason why we are changing the symbol is because X bar was about a set of data, okay? Mu is about the probability distribution, okay? So it's a little different. Both of them talk about means, but one is actually about a set of data, and this one is actually about the probability distribution, okay? So we call it mu, So this is the lowercase Greek symbol for mu. And then we have this one. This is lowercase sigma, and that's going to be the standard deviation of the probability distribution. Again, we have lowercase s for a sample of data. Okay, just like X bar was for a sample of data. This now represents the standard deviation for the probability distribution. And then when we put it together, normal curves can be written as such. It's a capital N that's italicized, and then the first number you get is mu. The second number you get is sigma. Okay, so they tell you the mean, and then they tell you the standard deviation. Okay. And last but not least, please remember that because these are symmetric, the mean is in the middle, and the standard deviation determines the shape. Okay, the standard deviation determines if you're wide and low, because you have a large standard deviation. Remember back when we talked about samples, the larger the standard deviation, the more spread out your data would be. So this mimics that information. Large standard deviations means that you have a wide set of data, you're spread out, and it's not as tall. Okay, so the middle is pretty low. Or you have a narrow and tall distribution. Okay, a narrow and tall curve, which means that it has a small standard deviation. The smaller the standard deviation, the more compact your data is, and the more it will make your curve be tall. Okay, the standard deviation determines that. The mean is always in the middle of the curve. All right, which relates a lot back to the empirical rule. Okay, so now instead of calling this X bar plus or minus the standard deviation, it's mu plus or minus that standard deviation. But it works the same way as what we just talked about back in chapter 3. It works the exact same way. Okay? And then you can see all those percentages that we talked about before. All right? So just now, I've changed it up with mu and sigma. Okay? So sometimes a lot of these problems that we're going to deal with, just knowing the empirical rule and or knowing this picture right here can help us out a lot. All right? Because a lot of the things that we're going to be after are going to be the percentages. Okay? All right. So let's take a look at some things. So when we want to find probabilities, because that's the big thing in 6.2, we are after probabilities. And basically, which is the area under the curve, like you saw at the end of 6.1 with that graph, okay? The one where we found the area of the rectangle. Well, but now they're curves, okay? So the first thing you're going to want to do is sketch the curve, which is a lot like what we did back in chapter 3 when we sketched the curve and we put the mean in the middle and we were adding the standard deviation to the right and subtracting the standard deviation to the left. All that is going to help us, okay? And then the second step is going to be to find the probability. Sometimes we can just easily use the empirical rule, or if the empirical rule doesn't fit it, then we'll use technology. And I will also show you how to do this by hand. It's not hard by hand. But if we can use technology, why not, right? So here's an example. So this is that normal curve we were talking about. And it says we can use the empirical rule on this, which is even better. Okay? So it says, assume the college women's height are approximately a normally distributed. So it's a normal curve. That's what that means. With a mean of 65 inches and a standard deviation of 2.5. On the horizontal axis of the graph, indicate the heights that correspond to the z-scores. Okay, so again, z-scores are just standard deviations. So this means 1 standard deviation, 2 standard deviations, 3 standard deviations. We've done this, okay? And then it wants to know 60 inches is 5 feet and 72 inches is 6 feet. Okay, so they're kind of giving us some information there, which is fine. But everything that's down here is all about inches, if I remember right. Yes. All these probabilities we're finding are 60 inches, 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 inches. So, I mean, they're just giving you some extra information. Yay. Okay, so first things first, we need to fill in our numbers, just like what we've done before. So remember that right here in the middle, this is the mean. This is mu. Okay? It's actually got a little tail in front too. So what is our mu? Right up here it said 65 inches. And they could have also given it to us like this if we're talking about that notation. Could have been capital N 65, comma, our standard deviation or sigma is right there, 2.5. That's how this could have been written up if they really wanted to, which means normal distribution, your mu is 65, standard deviation 2.5. So let's get the rest of these guys. So this right here is mu plus sigma. This guy right here would be mu plus 2 sigma, because it's 2 standard deviations above, just like what we did before. So in other words, to get right here at 1, we're just going to take 65 plus 2.5. So that is 67.5, just like what we did before. To get to the next guy, to get to 2, all we're going to do is we could take 65 plus 2 times 2.5, or 65, or sorry, the 67.5 plus 2.5, which would be 70. Okay? And then last but not least, the last area right here would be 72.5. And then all we're going to do is just work it backwards by subtracting. Yay. So 65 minus 2.5 gives us 62.5. 62.5 minus 2.5 is 60. And 60 minus 2.5 gives us 57.5. So that's what they're saying right here. It says on the horizontal axis, provide us the heights, okay, to the corresponding z-scores. And these are z-scores, but you can also think of them, z-scores are really just how many standard deviations are you from the mean, okay? So now we're going to answer some questions based off of the empirical rule. Oh, it looks like I skipped over one. Okay. So based off of this picture that's right here. So I'm going to stick a pin in this, and I want to do a dual page. So I'm going to pin that page. Accidentally skipped over a question. So let's answer some things. Here it says, roughly what percentage of women's heights are greater than 72.5 inches? Okay. So we are greater than that. So right here is 72.5. Okay. Now, if you remember, between 3 standard deviations is 99.7. So if we are greater than that over here, so what you could do is you could think about this. Remember, this whole curve has to add up to 1, right? Well, if I take 1 minus 99.7, sorry, 100 minus 99.7, because that's the percentage, and that should be 100, not 1. I get 0.3. Okay, so out here, these little bars make up 0.3%. Well, but again, both of these should be equal. So if I cut that in half, 0.3 divided by 2 is 0.15%. 0.15%. So you can add that to your picture if you want, because that's true. So again, going back to this, we want to be this direction. So how much is that? Well, it's about 0% because it's 0.15% out there. Hopefully that makes sense. So see, we're just using this picture to figure out what we want to know. Okay? All right, so let's take a look at some other ones. And if you want those 0.15 out there, keep those out there. Okay? So now it says we want to be between 60 and 70 up here. Okay, so I'm going to do a little bit of erasing right here. So 60 and 70, here's 60, here's 70. We want to be between here. Well, that's between two standard deviations. And when you're between two standard deviations, you are 95%. See how easy that is? Roughly what percentage of women's height are between 65 and 67.5? Okay. So we can come in here, and I'll need to grab this information. And we're looking at between 65 and 67.5. So that's here and here. This is why I gave you that picture. So we are one standard deviation above. That's it. So that's this guy that's right here. So that is 34%. See, easy peasy. Roughly what percentage of women's height is between 62.5 and 67.5? So if we come back, oops, I don't want to do that. If we're looking at it this time, 62.5 and 67.5, that's right there. So we are between one standard deviation. So that's this full length right there, which is 68%. Nothing crazy that you're doing here. Roughly what percentage of women's height are less than 57.5? Okay, so again, we're kind of doing the opposite of what we did at part A here. So we want to know what percentage of women are less than this. So we want this guy that's down there. Well, again, that's going to be about 0. And then last but not least, what percentage of women's height are between 65 and 70? Okay, so they want to know between 65 and 70. Well, that's one standard deviation above, and well, basically 1 or 0 to 2 standard deviations above. So if we go over here, that's 34% and 13.5% added together. So how much do we get when we add those two together? You get 47.5%. Okay? See, sometimes it's just using that empirical rule, nothing crazy. And it's about looking at what you know. Okay? All right. So I did skip over one. So let's go back. Go ahead, pause the video and do this one. Again, they have given you the numbers down here. I meant for the one that we just did to be yours, but you know, I messed that up. So they did give us the numbers down here, the IQ. Go ahead and let's not do all of this because you pretty much get the picture. Go ahead and do A, do B, and do C. Go ahead, do those 3. Pause the video, Go. Okay. So the first guy, again, this is the mean. That's our mu. And then we've got our 1 standard deviation above, 2 standard deviations above. I like to draw on my little lines so I can, close stuff off. Technically, these should be the same height, but neither here nor there. All right. So we want to be more than 100. So that means we're going to start at 100 and we're going to go this way. How much is that? Well, that's half of my circle, half of my curve. So that would be 50% of my data. From the mu above or from the mu below, that's 50%. Because remember, the mu is in the exact middle. Okay? All right. So let's take a look at the next guy. So it says between 100 and 115. So there's 100. There's 115. That's just 1 standard deviation above. So that's right here. So 34%. Okay. And then last but not least, did not mean to do that. We want to be below 55. So here's 55. We want to be below that. Okay. So again, just like last time, when you're outside there, it's like 0.15%, which is about 0. So hopefully that's what you got. So that right there is some of your problems. If we can use the empirical rule, why not? It's a little bit faster. And if you really know this chart, it's super quick. Okay? All right, so let's get out of this dual page because we are going to go, and it's not pinned anymore. Good. We are going to go beyond this now because not everything fits the empirical rule. Okay? So when stuff doesn't fit the empirical rule, we rely on our technology. Okay? What you see right here, this is kind of a view like what SnapCrunch. God, I'm about to say Snapchat. StatCrunch looks like when we want to run mu and our standard deviation and figure out pieces of information. This is our density curve. This is our normal curve. Okay? And notice that here's mu. Here's 1 standard deviation, 2 standard deviations, 3 standard deviations. Notice that what they're having us look at, 24, is not right on the empirical rule. Okay? It's not right here at 1 standard deviation, but they want to know what's the probability. Okay? So this is where technology comes involved. Or we can do this by hand. Okay? So what we're looking at here, it says this gives us ACT scores are approximately normally distributed with a mean of 21 and a standard deviation of 5. So you can actually see that information down here. Here's the mean, 21, standard deviation, 5. So here's mu, here's sigma. Okay? They want to know what is the probability that a randomly selected person scores 24 or more. Okay? So looking at this, if you look at this little symbol right here, that's the less than. So what you're looking at right here, what this thing is kicked out for you right here, this is the probability of being less than 24. How do you think we can find the probability of being more than 24? I want you to pause the video and figure out the answer to this question right now because you have enough information. Remember, this is all about being less than because that's what this is. This is the less than or equal to. But we want to be 24 or more. Figure out that probability. Pause and go. Okay. So, based off the technology, we know that 0.7257467, or in other words, about 72.6% scored 24 or less. Okay? But we want to be more. So again, think about this. Probability is all out of 100%. Or in this case, this is the decimal version of it. It's all out of 1. Everything under this curve adds up to 1. So if I want to get the other side here, which is what I care about, the red and the green must add up to 1. So if I take 1 minus that guy, that should be my probability for the green section. So if you go to your calculator and take 1 minus 0.72574687, you end up with 0.2742513. Now, they might ask for this as a decimal, rounded to 4 decimal places. So if you round to 4 decimal places, they would say 0.2743. It might ask for the percent. So you just multiply it by 100 and you would say 27.43%. That's the probability of scoring 24 or more. See, nothing crazy. Okay, we can have that technology help us out when they are not quite, when we are not quite able to use the empirical rule. Nothing crazy, see? Just a little bit of probability. All right. So there is another version of the standard normal, or of the normal curve, the normal model that we could use. It's what we call the standard normal. Okay. And so when you're looking at this, kind of alluded it to before. So we could have actually looked at all this information based on the z-scores. And remember, when you get a z-score, and when you base everything according to a z-score, you are now unitless. Okay? So if I wanted to think about this problem, and I wanted to know what's the probability of being greater than 72.5, I could say, what's the probability of being greater than 3 standard deviations? I could have said, what's the probability of being between 60 and 70, which is, what's the probability of being between -2 standard deviations and 2 standard deviations? Okay? So what we call the standard normal curve, instead of actually dealing with the units that we have up here, we basically just convert everything into z-scores. So it is the normal model in terms of standard units, z-scores. Okay? And in the normal model, your mu is actually 0 because you are 0 units away from the mean. And then the standard deviation is 1. Okay? We have what is called the standard normal distribution table. It's here in your appendix on page A2 and A3. And I have provided that for you. I went ahead and took a picture of it and made a PDF for it. This is that table that's on A2 and A3. And what these are, these list the probabilities of pretty much every z-score all the way out to -4 and all the way up to a +4. Okay? So these are all the probabilities that are possible. How you read this, when you deal with the z-score, okay, you're going to need your z-score to be 2 decimal places. This is why back in chapter 3 and when we were talking about it for the exam and during the review and during the video, why normally I said, hey, round your z-score to the nearest hundredth, because you need 2 decimal places in order to read this chart. So over here, this is your z-score to the 10th. And then once you know what the 100th place value is, that's where you're up here. Okay? So if I'm looking for a z-score of -3.82, okay? Again, that was -3.82. My 10th is -3.8. So that means I'm in this row. Because it is 0.82, the hundredth was 0.02. So if I want to know what is the probability at negative 0 or negative 3.82, I go to 0.02, negative 3.8, and there's that probability. Now, everything that's on this table is to the left of that z-score, okay? So this is if I'm looking for the probability of shading to the left. All right? So if I'm looking at my curve, let me go back. This is what we're looking at. The red shading here. Every probability on here is that red shading. It is to the left of that z-score. Okay, super important to know. And I'm going to show you how this works again here in just a second. We're going to do a problem where we use technology and where we do it by hand, because it's all about z-scores, and we know how to convert stuff to z-scores. Okay? So we have what is called the normal standard model, which is basically taking what we've talked about before, and we would just turn all this into the z-scores like what we had down here. Actually, if I didn't have this information up here, okay, if I didn't have all my purple and blue stuff up here, this would look like the normal standard model. Okay, because all this is your z-scores down here. Cool? Yes. Good. I'm glad you agree. All right. So let's talk about how we find probabilities doing the normal. So you convert what you're looking for into a z-score, and then you're just going to look up the area, or you'll just run it on your calculator. That's how you find it. And then and that's how you find your probability. We'll talk about percentile here in a second and how these two relate. But if you want to find the percentile, it's the same situation. You'll understand why here in a moment. Okay? So again, convert what you're looking for into a z-score, and then you're just going to look it up. Now, if you're looking for below the value, okay, and this is what I was talking about a moment ago. If you're looking for below that z-score, then this table has the answer for you. Okay? All of these are the probabilities that are below the z-score. Okay, so like say right here, the probability of 0.00114. That is the probability of the z-score negative 3.05. So right here, this is the probability for negative 3.05. And that is shading to the left of that. Okay? So everything on here is all about shading to the left, or in other words, below the z-score. If you want to be above, just like what we talked about a moment ago. Remember, everything under this curve is 1, adds up to 1. So if I want to be above, I just take 1 minus that probability. Okay, so once you look up the probability for your z-score, take 1 minus that, and that will give you the probability above. If you want to be between, you have to do two things. Look up the larger z-score, then look up the smaller z-score probability and subtract the two, and that gives you between. Pretty easy. Just a little bit of adding and subtracting. That's all that's going on. Okay, well, actually, not even adding, just subtracting. All right, so let's do some things. First, let's talk technology. All right, so in here, according to the data from the College Board, it says the mean quantitative stat score for females, college bound at a high school, is 500. So you know the mu. 500. It says assume that the SAT score are approximately normally distributed and has a population standard deviation of 100. So now you know sigma. Okay? What percentage of female college-bound students has a score of 675? So our data value is 675. All right, now you can approach this one of two ways. All right, we can keep it this information and our calculator can deal with it as such. Okay, because we're dealing with a normal curve here where it is 500, 100. Or we could deal with this as the normal curve. Okay, the standard normal, which the 500 would turn into 0 because that's the mean, which would be at 0. And the 100 is one standard deviation away. And that means we would have to turn our data value into a z-score. Okay? So remember, we know how to find z-scores. You just take your data value minus the mean. So our formula changes a little bit because it's got to be based off of mu now, divided by the standard deviation. So our z-score formula just changed a little bit. So instead of being about a data set, where it was x bar and little s, it's now about mu and standard deviation. It's found the same way. So if we just plug in, so our z-score is going to be equal to 675 minus 500 all over 100. So you go to your calculator, 675 minus 500 is 175 divided by 100 is 1.75. Okay? Now you know the z-score, and we can use that. So it says up here, if we look carefully, now you got to pay attention to the wording. Right here, it says they want you to be above. Okay? Not below, but above. So let's talk about how our calculators are going to help us out. Let me show you how to do this with the graphing calculator first. Graphing calculator. So second quit. Again, we're going to go under distributions. D-I-S-T-R. Distributions right there. So hit second and vars. You're going to come down here and you're going to do the normal CDF. Don't do the PDF. I know that's what we're talking about, but you need to do the normal CDF. Okay, trust me on that. So we want to be above. So one thing you have to be careful on here is make sure that if you want to be above, we need to put a number here. Okay? So if we want to be above, instead of having negative 1 e to the 99, we're going to put right here for above a positive 1. Second, here's your EE, the comma. So second, comma, and then 99. Clear that guy out. So now we're above. Okay? If you want to be below, then you would put negative 1 E99 there. So just so you know, we'll kind of go back and we'll mark this for the TI-84. When you are above, make sure you put in a 1 E99 for the upper. When you are below, so in here it says below, put in a negative 1 E99 for the lower. Okay? All right. So now we come back here to our calculator. And what was our lower value? That was the 675. Okay? And then we can come down here and we can put in the 500. And then you can put in the 100. And then it's going to, then you're going to scroll down, not 1,000, 100, and paste it. Okay? And this will give you the probability of being above. Pretty cool. Calculator, you don't have to worry about any of those tricks that I talked about a moment ago right here because the calculator does all this for you. This is if you're looking up the area, not using a calculator. So this is being above, because see, we want to be from 675 and above. Okay? And then I just put in my mu and I put in my sigma. Hit paste and then just hit enter. And there's your probability. And again, it probably will say round to the 4 decimals, or it might say give us the percentage to the nearest hundredth, which will be 2 decimal places. So if you round to 4 decimal places, it'd be 0.0401. So based off of this information right here in green, because that's what we put in, so you don't have to do the standard normal. You could just put in that information. So 0.0401, or as a percent, 4.01%. Okay? Or if you wanted to, you can run it as the standard normal. So if I come in here and do second distribute, and here we want to be above, and it's 1.75. That is our z-score. There's the upper. Down here, you would have left this alone because they originally had 0 here and 1 there. So you could also do it like that, where this is in terms of the z-score. Hit paste and hit enter. Same answer. So you can do it one of 2 ways. It's your choice. Okay? Now, usually on these problems, it does say it wants you to draw the picture. Usually it says that. Please include a well-labeled normal curve. Yeah. So it usually wants the answer, wants a picture of the curve. So the calculator, we can do it on there, but that's really going to come in later on. If I remember correctly, second distribute, and it's the draw feature right there. And you're going to do a shade normal. And then again, you can just put in the same information. Okay. But I like StatCrunch because it will actually give you all that picture, all that information right away. So if you did 675, and then you scroll down to the upper, and you did 1E99, and then 500. Oops. So we were under draw. Sorry about that. 675. Scroll down. 1 second E99. 500. 100. You can tell it what color you want it to shade. It doesn't really matter. And draw. And then there's that picture. Although it shouldn't have looked like that. Oh. Hit zoom. And we want, I believe it's going to be stat. Or actually maybe just quadrant 1. Let's see what that does. It's been a while since I've done this. Nope. So let's say zoom stat. This is why I don't usually use the draw feature. No, it's not even getting it out there. Huh. So shade normal. We had all of our stuff in there. I don't know why. I'll have to look into that and then get back with you guys on that. So yeah. Sorry about that. But that's where you would do the drawing information. As soon as I can remember how to fix a window, I'll let you guys know. But it's all good. So there's your probabilities. But if you wanted to, you could easily hand draw this. So normal curve. And right in the middle, you could say 500, or just put 0 down here. And then that would be 1. That would be 2. And you're at 1.75. Or this would be 600. This would be 700. So they want you to be above. This would be the shading of the area. Okay? So that's the kind of picture. StatCrunch will do all that for you. Let's talk StatCrunch real quick. All right. So again, in your calculator, you can do it either way. You can actually put in the real mean and standard deviation and the actual value. Just make sure that you accommodate the above and below. Okay. And also, if you're in here and you're between, well, between should be pretty self-explanatory. If you're between two values, then put the lower value here, the higher value there. Or once you know the z-scores, you put the lower z-score there, the higher z-score there, and it will figure it out. Okay? So if you're between, then you just put in your values. Simple. StatCrunch. So in StatCrunch, we're going to go to Statistics, Calculator, Normal. See, hey, look at that. It brings up a curve. If you are looking to do above or below, come on, you. Whoa. Shrink you back down there, pal. All right. Well, so if you're looking to above or below, that's what's controlled by the greater than or less than. Choose less than when you want below. Choose greater than when you want above. See, it switches sides. Wee, back and forth, back and forth, back and forth, back and forth. There you go. So we want to be above. And then all you got to do is put in your information. So you can keep it normal and just put in the 1.75 down here and say compute. See, there it is. There's the picture. And then there's the probability that we found. Okay. Or if you wanted to, you can put in the actual mean, the actual standard deviation, which was 100, and then put in the number you were looking for, 675. Compute. Boom. There it is again. Notice it changed everything up for you down below, where it was it's in terms of the mean and the standard deviation now, where before it was in terms of the normal curve, was 0, 1, 2, 3, -1, -2, -3. If you're between, you come up here and you click on between. Then you put in your information. Okay, your lower number, your higher number. Okay, and there to go. And it will shade all that stuff up here. So you just switch between those two. It'll give you the picture and it will give you the probability down below. Oh, there you go. Easy peasy. So there's how you can use either StatCrunch or the TI-84. Again, I like StatCrunch. It's really user-friendly. The TI-84 can be a pain. Okay, especially, you know, when you saw me trying to do the draw feature, because I forgot how to do the draw feature, because normally I don't mess with the draw on here. Okay, so there we go. Moving on. There's your technology. Just let it do the hard stuff for you, okay? But it is good to know how to do stuff by hand. Okay, so I'm going to show you how to do this by hand. And then also we can talk about how we can do this in the calculator and all that stuff. Okay, so right here it says, according to the National Vital Statistics, the average length of a newborn baby is 19.5 inches, with a standard deviation of 0.9 inches. The distribution of lengths is approximately normal. Use a table or technology for each question. Okay, and you should include the normal curve shaded. So again, here's why StatCrunch would be a lot better for a choice for you. All right, so first things first, we know that mu is 19.5. We know that the standard deviation is 0.9. Again, if you want to talk about this in terms of normal, standard normal, this would be 0, this would be 1. Okay? Then over here, these are the values they're giving us. They want 20.4 or more. So that means we want to be above because of the more. If it said 20.4 or less, then that means you would want to be below. Okay? If it wants you to be between two values, notice it will say between. Okay? So pretty easy. You see the word more, that means above. You see the word less, that means below. Okay? Or it might just say above this or below that. Easy peasy. Just read carefully. All right. So here's our data value. We need to turn that into a z-score if we wanted to. Okay. So let's me do some erasing here. Let's underline this in green since I kind of started with green with the z-scores. So our z-score is going to be 20.4 minus 19.5 all over 0.9. So you go to your handy dandy calculator, 20.4 minus 19.5 divided by 0.9. And that gives you 1. Okay? Well, that's not bad. So as a decimal, we would want to know that that is 0, 0, though. So it's 1.00. You need your z-score to have 2 decimal places because that's how we're going to look it up on the chart here in a second. Okay? So if we did 21.4, because that's the next guy, turning that one into a z-score. And again, this guy wants more. So we'll talk about that here in a second. So the z-score for this guy is 21.4 minus 19.5 divided by 0.9. And so you go 21.4 minus the 19.5 divided by 0.9. And this guy is 2.11. Okay? And then down below, here you're stuck between 2 values. So you would actually need to find both of those. So the z-score for the 18 would be 18 minus 19.5 divided by 0.9. And the z-score for the 21 would be 21 minus 19.5 divided by 0.9. So 18 minus 19.5 divided by 0.9 gives us negative 1.67 when rounded, because technically it's actually 6 repeating. Okay? And then the z-score here, 21 minus 19.5 divided by 0.9 is a positive 1.67. Okay? Because again, it's the 6 repeating. So now that we have all of our information, we can do one of 2 things. We can run it for the way it is, or you can run the z-score for it. And actually, since my normal numbers were in red, let's change those to red to kind of correspond. Okay, so if I was going to find this by hand, I have to use the z-scores, just so you know. So if I'm going to use the z-score here to find this guy, I would go to my chart, and I'm going to look up 1.00. So first I need to find 1.0. And here it is. Here's 1.0. And then my 100th is a 0. So here's my probability. 0.84134. So this is for part A. To the left, or in other words, below, because that's what this guy is right now, 0.84134. 134. 134. Because remember, our chart gives us everything that's below that. That's the probability if I'm looking at a curve. Because remember, right here in the middle is 0. And this guy is 1. So that's this probability right here. But that's not what I want. I want to be above. So as I said over here, if you want to be above, all you need to do is take 1 minus that. Okay? So all I want to do now is take 1 minus 0.84134. So 1 minus 0.84134 is 1, or sorry, 0.15866. And if they wanted the percentage, you can call this 15.866%. Again, I don't know where it's going to have you round, so I'm just going to keep it as that. There's the answer for part A. We could have used our technology too for this. Again, we can just go into StatCrunch. I'm not going to go back to the calculator. I like StatCrunch. And we could have put in the 19.5 and the 0.9. We want to be above, so we want the greater than. And the value was, going back to this, 20.4. 20.4. Cute. See, there it is. Okay. And there's that graph, which is what I showed you right here, although we were looking for this side of it. That's the percentage we wanted, not the red stuff. Okay? So go ahead and try B and C on your own. Use the table. Okay? Try using the table. Because if you're going to do this by hand, you have to convert them to z-scores, because our table doesn't have normal data information. Okay? And go. All right, so part B, our z-score was 2.11. But we want to be above, so I'm going to have to take 1 minus the z-score that I find. So my first part was 2.1, so I need to find 2.1. And my 100th was 1, so that would be this guy right here. 0.98257. So 0.98257. So 1 minus 0.98257. Sorry, I missed the number. 98257 gives you 0.01743. Or as a percent, that's 1.743%. And there you go. And then last but not least, for part C, and of course, if you drew a diagram, it'd look a lot like this, but you would have the shading up here, and this would be like, this would be at 2.11. Nothing crazy. So part C, we have two z-scores we need to look up. So negative 1.67 and positive 1.67. Okay? So the first thing I need is negative 1.6. Okay, I know I'm going a little high for this, but I need to know where that last column is. There's the 0.7. So negative 1.6 and 0.7, here it is. So 0.04746. 0.04746. That's the lowest one. 0.04746. And we're going to subtract that from the larger one, which is 1.67. So we're going to go to 1.6. And then we need the 7, which is right here. There's the 0.07. So that's 0.95254 or 0.95254. Okay. So 0.95254. So all we got to do is subtract those. Let me double check that. That seems weird. 0.952. Okay. So 0.95254 minus our other number, which was 0.04746, gives us 0.90508, or as a percentage, 90.4%. 0.508%. Okay. Again, I would go to StatCrunch, and let's look at StatCrunch with a between. So if I go out here to StatCrunch, I would click on between. Okay. And our mean is there, our standard deviation is there, and then you can just put in the two values. Our lower one was 18. Our top one was 21. Let me just make sure on that. Oops, wrong page. Yeah, 18 to 21. So we go back to StatCrunch. Compute. Hey, look at that. There it is. 0.9044. What did we get? I know we got 0.90. And that was because I rounded these up to the 7. So you got a little bit of rounding error. This is why the calculator would be better, because the calculator is so much more accurate than what we could be by hand. Because again, we had to do a little bit of rounding because it was 0.6 repeating. Okay, and there's what it looks like. If you did it in the normal, then it would look like this: 0, 1. This would be negative 1.67. Again, there's going to be rounding on this, and a positive 1.67. So this should be more, yeah, see, that one's closer to the answer that we got. Okay, because again, we rounded. So there you go. Now you know how to do it by hand. You know how to do this with technology. It's not really crazy. Okay. It's all how you want to do it. Do you want to work with the regular data, or do you want to turn it into the standard normal and work with z-scores? Standard normal is pretty cool because that allows you to compare any distribution to each other. Okay, because remember, it takes off the units. All right. So percentiles. Percentile just means it is those that are out or below that item. You've seen percentiles when you take the SAT, the ACT, or when you took those state exams when you were in high school and they said you scored at the 75th percentile. That means 75% of the people scored with you or below you. Okay? That's what a percentile means. They either scored the same as you or were below. So technically, it's kind of like you beat out 75% of the people. Okay? That's a percentile. And when you are using that table, that probability that you find is the same thing as a percentile. Because when you're looking at your curve for those people, let me actually get to one. Right here, this red, this is the probability of that red. That means 84% of the people are one standard deviation or below. That's the same interpretation as a percentile. This is at one standard deviation, you are in the 84th percentile. Because that means 84% of the people are either with you or below you. Okay, so percentile and the probabilities that we've been finding are pretty much the same idea. Okay, percentile just means those are at or below you. Okay, so now, reason why we kind of say that is because now you might be looking for a measurement. Okay, if you are looking for a measurement because they give you the percentile, you're going to be performing what we call the inverse normal. You're working the idea backwards, hence why we call it inverse normal. Okay, so this is kind of a note. If you're looking for a measurement, you're doing what we call the inverse normal. If you're looking for the probability or the percentile, then you're just performing normal probability. That's what we've been doing up to here. Okay, everything from here and on back has been performing normal probability. But now I want you to know that sometimes you're going to have to perform the inverse. They're going to give you that percentile or probability, and you got to work it backwards. So if I score at the 87th percentile, what was my original measurement? Okay? So let's take a look at that. First things first, I want to make sure that you understand what I just said to you. So it says the normal model N 65, 2.5. Hey, that sounds familiar because we dealt with that right at the beginning. Describes the heights of college women in inches. Which of the following questions asks for probability and which one asks for a measurement? And again, remember, measurement means you're doing inverse normal. So you're going backwards. So it says, what is the probability that the random college woman has a height of 68 inches or more? And then part B says, to be in the tall club, a woman must have a height such that only 2% of women are taller. What is the height? So in here, I want to know, is this probability or is this a measurement? Is this probability or a measurement? Pause the video and tell me. Go. Okay. So hopefully you said this one was the probability. And again, this isn't meant to throw you off. It does say up here, what is the probability? Okay? And then hopefully down here, you said this was the measurement. Okay? Reason being, it says, what is the height? That's a measurement. Or another way, instead of saying measurement down here, you could say, I want to do the inverse normal. Okay? So you'll have a couple problems in your assignment where it's, hey, is this probability or is this a measurement? There you go. Nothing crazy. We're almost done, I promise. So let's talk about how we do the inverse normal. And that's the last piece of this, if I remember correctly. Yeah, and then I just got a couple more examples that we're going to work through. So how do we do the inverse normal? So the inverse normal says that you're going to find the z-score on the table. Okay? So basically, they're going to give you the probability, and you're going to go into the table and look that probability up. Okay? So we're going to use the table to find that z-score. Okay? And you're going to pick the probability, the value, as close to that percentile or probability is. So if it says 98%, if it says 98%, okay, then that means I need to come in here and find the percentage that is close to 98%. So I'm looking right here. So I'm stuck between these two numbers. So one of these is closer to 98%, and that's this guy. This number is closer to 98% than this one is. Okay? So then that means my z-score would be 2.05. So if I wanted 98 percentile, gosh darn it. All right, so if I wanted 98 percentile, I hate that blue background, but whatever. I would have to have a z-score of 2.05. That would be a 98 percentile type score. There we go. Sorry. That blue background annoys me. And then you can convert this z-score back into its units, just like what we did back in chapter 3, where we went backwards and we've converted z-scores back into what their normal units were. So a little bit of chapter 3 coming back at us along with that table that we're using. So let's do some of this. So right here, we want to find the z-score. So this is the first part. We're going to find the z-score that represents the left area. That means whenever you're talking left area, that means below. Okay? So we need 0.7123. We need a z-score that is as close to that as possible. All right, so let's go to our table. So 0.7123. So we got to scroll up. Okay, so here we go. 0.7123. So I got 0.7126. That's too high. That's definitely too low. So here it is. This is the one that's closest to it, 0.7123. The closest I can get is 0.7126. So what is that z-score? 0.5. 6. So 0.56. So there's our z-score. 0.56 is the z-score. That's as close as I can get. Okay? I think that was right. Right? Let me go back and look. Yeah. 0.7123. So 0.7123. Yeah, that's as close as what I can get. Okay. So you try the next one. Go. All right, so 0.1587. And again, to the left, so that means we want to be below. So we don't have to do anything weird here. So, sorry, I forgot my number. 0.1587. 0.1587. So that's going to be around in here. So 0.15. Here's some fives. And it said 87. 1587. This is the closest because that's just too low, and it's 0.11. And that one, I mean, it's kind of close, but we want 0.1587. So that's just, this is much closer. So that would be negative 1.00. There you go. So negative 1.00. All right. And then if we knew about the mean and the standard deviation for this information, we could take and convert that back into its original unit, whatever it might have been. Okay. All right. So let's take a look at this one. It says, according to the College Board, the mean SAT score for college female-bound students is 500. Okay. So we know mu. We know that the SAT scores, the standard deviation was 100. Okay. Oh, I didn't show you how we could do this on the calculator. Well, we'll do that here in a second. Okay. I'm going to show you how we work backwards on the calculator because our calculators can help us out. And same thing with StatCrunch. All right. So it says the scholarship committee wants to award awards to women who score at the 96th percentile or above. Okay. 96th percentile or above. All right. So they want to know what is the score. So this is where we're definitely working backwards. Now, you got to be careful with this because this says the 96th percentile or above. Okay? So this is a little misleading because percentile is all about meaning that it is below. So what they're really telling you is right here, they are giving you the probability of the curve below, right? So they're giving you this information. '96th. Okay? Or above. You know what? I think I just probably confused you because I'm thinking to myself, you're good. You're fine. This is fine. This 96th percentile is exactly what we needed. We don't care about the above part because all we're doing is we're looking at the score, right? So we don't even care about that. I'm sorry for confusing you there for a second. But if they were looking for the curve part of this, just so you know. So if you have to draw the curve on this, this is actually what they're looking for. This is the 96th percentile. They're looking for this part of the answer. That's the curve. But what we're looking for is what is this score? Okay? That's really what we're after. But the picture, again, says 96th percentile or above. That's what they want, at the 96% and above. Okay? Okay. So let's go ahead and work this backwards. That's what I was trying to get at a second ago. But again, in the end, we're just really after the score. Okay? So what we know is that whatever our z-score is, it's got to have a probability of 96%, or as that decimal, 0.96. So I need a probability that is, I need a z-score that is close to 0.96. So we go to our table. 0.96 is going to be down here. All right, so 0.962, 0.961, 0.960, 0.95999. So between these two, the one that is closer is right here, because this is, I mean, really close to 0.96. This one is just a little bit further away. Okay. So this is actually your closest call. So that would be a z-score of 1.7. Then we need to scroll up 5. Okay. So 1.75. Let me just double check, make sure. Yeah, 1.75. So there's our z-score. So use this information and work it backwards. You know the z-score is 1.75. We're looking for x minus the mean, which is 500, divided by the standard deviation. Okay? So you cross multiply just like what we've done before. There's a 1 under this. So 1.75 times 100 is 175. Equal to 1 times x minus 500 is x minus 500. Then all you need to do is add 500 plus 500 plus 500, and our score, that is 96th percentile, is 675. So anybody that scores 675 and above, we are going to give an award to. That's what they're after. So I erased that curve. Let's go ahead and redraw that curve back in. So anybody that is right here at 675 or above, they get the award. That's what they're after. Okay? Because this represents the 96th percentile and above. Now, let's talk calculator. How can we do this on the calculator? All right. So on the TI-84, if you hit second distribute, right there, number 3, inverse normal. Scroll down to it. Tell them the area. So we're looking at 0.96. Give them the mu, 500. Give them the standard deviation, which is 100. Now, the tail on this, remember, this is the percentile, so that means it's all to the left. Always figure this information to the left, okay? Don't worry about anything else over here. Figure it out to the left. Hit paste. There it is, 675. Okay? And there you go. Cool beans? Make sense? Yes. Good. I'm glad you agree. If we did it on StatCrunch is even easier. So in StatCrunch, this is what you're working with. Okay, so we're going to go back to this. And what you're going to do is you're going to delete this information out. Okay. And you're going to fill in all the pieces that you know. Now, because we want a picture on this one, we actually do want to tell it if it's above or below. So we want to be above. Okay. We're going to put in our mean, which is 500. We're going to put in our standard deviation, which is 100. And then down here, we're not going to put that guy in. We're going to fill in the equal part, which is 0.96. Always has to be the decimals when you put it into this or into the TI-84. And say compute. Ah, sorry. We should have been the below. My fault on that. Okay. So let's say below, compute. Well, that's weird now. Oh, I know why. 0.96. There we go. There it is. So again, just like everything else, because that was a percentile. Again, forgive me, percentiles are always below you. Okay. But the picture that it would be after would actually be this white area that's right there. Okay. So I wonder what we'll do. There we go. So that's what you would have to do in the end. This is the actual picture, but in order to get the original score, you always got to figure it to the left. Okay. Always got to figure to the left. But our actual picture wants this information right there. Okay. All right. So let's take a look at another one. All right. So showing you how to use your calculator. And again, we could have used our calculator on these as well. Actually, yeah, we could have, because we could have done it on a normal distribution, because we just want the z-score. So let me show you how the calculator works on these. So if I did this one, second distribute, go down to this, and do it on the standard normal. So our first decimal was 0.7123. Okay. So if we say 0.7123, let mu be 0, let sigma be 1, because we don't actually know what the data is, so you got to use 0 and 1. And then enter, or scroll down. There it is. Hey, there's our z-score that we came up with. And let's see how well we did just with our estimating. So 0.56, yeah, pretty darn close. So there you go. If you're doing this on StatCrunch, so again, we'll be working here. Again, you want to work to the left. And we're going to clear this guy out. 0.7123. The mean has to be 0 because we don't know the information about the standard deviation and all that. And 1 because we're going to do it on the standard normal. And hit compute. Hey, there it is, 0.56. Okay. So if you're looking for the measurements, you're going to leave the measurement part blank, and you're going to fill in the probability and then your information. Okay, that's how we work it backwards. All right. Last problem. Go ahead and pause the video and give this one a shot. Go. Okay, now I'm not going to look this one up. This is so much easier if we just use the calculator. So 90th percentile would be 0.90. We have our standard deviation, so there's your sigma, and then we have our mean, which there's the mu. Let's just go to the calculator, fill it in, and get this stuff done. And this is a lot of what your assignment is going to be like. You're just finding probabilities, or you're going to find a measurement. So we've got 3 ounces and 0.4 ounces. So let's put in the 3. Let's put in the 0.4. We know our probability is the 90th. Okay, just to make sure. Yeah. And then all we're going to do is hit compute. And there's our measurement, 3.5126. Let's take it to 4 decimal places. So 3.5126. And there's the answer for part A. 3.512.6. Nice and easy. Okay. And then last but not least, part B. Same process, except this time you're in the 10th percentile, so that's 0.10. Just go back to StatCrunch, change this guy out to 0.10. Hit enter. And there it is, 2.4874, if I'm going to round to 4 decimal places. So 2.4874. 2.4874. Done. And that's what 6.2 is all about, using that normal curve or the standard normal curve to find area, or in other words, probability under the curve, or to find measurement. So that completes the rest of chapter 6. So 19 through 50 is the rest of chapter 6. So all of chapter 4, all of chapter 6, do get it done, and your exam will be coming up shortly. Thanks for playing.